Good morning, students. In the last lecture, I was discussing with you how the superposition of two plane polarized light having perpendicular vibrations takes place. Here we have considered a double refracting crystal having optic axis parallel to its face. So we have here this is the face of the doubly refracting crystal and optic axis is parallel to this face, and a plane polarized light is incident on this. So a plane polarized light having electric vibrations in this direction is incident on this. Suppose this is x direction, this is y direction. X direction is also the direction of optic axis. This is the amplitude of the vibration, and this vibration is making an angle theta with respect to optic axis. So a plane polarized light is incident on this doubly refracting crystal having optic axis parallel to this face. Now what happens, this A vector, this will resolve into two parts, one parallel to optic axis. So here its component will be A cos theta. Its component will be A cos theta. Suppose this is given as E naught x, and this component will act as E ray. And here this component parallel to y, this will be A sin theta, and we have assumed that this E sin theta is E naught y, and this will act as a O ray. So now when plane polarized light is incident on this doubly refracting crystal and the electric vibration is making an angle theta with respect to this optic axis, then this A vector, amplitude vector or electric vector, it will resolve into two parts. One part will be parallel, one component will be parallel to optic axis, and this part will start acting as E ray, and one component will be perpendicular to the optic axis, and this component will start acting as a O ray. Now if T is the thickness of this crystal, both O ray and E ray, they will travel one after the another. They will travel T distance inside the crystal and they will emerge out of it. They are traveling equal distance T distance, but their optical path covered are different. One is covering mu naught O into T, another is covering mu E into T. Take the difference of T, these two, that will provide me path difference. So when these O ray and E ray, when they are emerging out of this crystal, they have certain path difference between them. So correspondingly we have a certain phase difference between them also. So if the incident PPL light is written as Ex is equal to Ex naught or E naught x sin omega t, and Ey component is E naught y sin omega t. This is the incident plane polarized light. If you divide Ey by Ex, then this will simply provide me E naught y by E naught x, which is a linear equation in Ex and Ey. So this is a linearly polarized light, plane polarized light. When this emerges out of this component will start acting as E ray, this component will act as O ray, and they will travel as E ray and O ray inside the doubly refracting crystal. When they will emerge on the emergent side, we will have electric field components Ex and Ey, and their values, their amplitude will not change. They will remain E naught x, E naught y, but an extra phase difference will be introduced. Suppose this is delta, and this will be sin omega t. So this is the emergent light. Now I want to find out either this is plane polarized, this is elliptically polarized, this is circularly polarized light. What type of light is this? So for this I have opened this bracket, we have combined these two Ex and Ey, and we find out an equation which can be written as Ex square this equation can be written as Ex square upon E naught x square plus Ey square upon E naught y square minus 2 times Ex Ey upon E naught x E naught y cos delta, and this will be equal to sin square delta. Later, so basically this is the equation of an ellipse. So on the emergent side, what we will have, in general we will have an ellipse, but the shape of this ellipse will depend upon this delta. So by choosing different delta values, I have discussed 4 cases with you. In first case, we choose delta equal to 0, 2 pi, 4 pi, 6 pi. You should remember in your mind all these 4 cases, and 3 more cases I will discuss today. So you should remember all these 7 cases. So first case is when part difference or phase difference introduce delta is equal to 0, 2 pi, 4 pi, 6 pi like this. Then we will have same plane polarized light on the emergent side. On the emergent side, we will have same plane polarized light, and electric vector of this emergent light will make exactly theta angle with the optic axis. In case 2, if delta introduced is equal to pi, 3 pi, 5 pi, 7 pi, odd multiple of pi, then again we will find out plane polarized light. So in case 1 and case 2, we are again finding plane polarized light. But what is the difference between them? Difference is, in case 2nd, the plane of vibration is rotated by an angle 2 theta. If this is the incident vibration, then on the emergent side electric vibration will be like this, and this emergent electric vibration will make an angle 2 theta with the incident one. So basically this electric vector will be rotated by an angle 2 theta around the optic axis. This is case number 2. This is the basic of half wave plate. In the later part, I will discuss half wave plate. So this is the basic case which is responsible for the development of half wave plate. Third part is when delta is pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2 like this, and theta, this theta is not equal to 45 degree. In that case, what you have on the emergent side, you have rectangular ellipse. So on the emergent side, we will have elliptically polarized light in case 3. In case 4, delta remains same. Delta is pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, but now theta is 45 degree. When theta becomes 45 degree, then this will be sine 45, this will be cos 45, and you are aware that sine 45 and cos 45 are equal. So E naught y and E naught x, they will be equal. And in this case, the elliptically polarized light, this will convert into circularly polarized light. So we have discussed up to this point right now. Now come to case number 5. Now come to case number 5. In case number 5, whatever is the value of delta, if theta is 0, in case number 5, then what will happen? Think about it. If theta is 0 degree, or you can also say that this is 180 degree. If this is happening, what is the meaning of this? If theta is this, the meaning of this is this electric vibration is parallel to optic axis. So what we have this type of situation. We have an electric vector which is parallel to the optic axis. So our electric vector is parallel to the optic axis. When electric vector is parallel to the optic axis, then its component perpendicular to this will be 0. So there is no perpendicular component. When theta is 0, our electric vector is like this, then it will not have any component in perpendicular direction. So what is the meaning? The meaning of this is there is no double refraction here. Only one component will be here, only E component will be here, and there will be no O component. So only E component, E wave will be present. There will be no O wave. There will be no O wave here. So this component which is incident as a plane polarized light on the doubly refracting crystal or on this retarding or on this plate, this will propagate as a E component or as a E wave, and there will be no double refraction. When there is no O ray, there will be no phase difference, there will be no part difference. On the emergent side, we will have the same plane polarized light. So if we have the electric vector of incident light parallel to optic axis, then there will be no double refraction, there will be no O ray, and it will propagate only as E ray, and on the emergent side we will have same plane polarized light. Now come to case 6. Case 6. In case 5, we were saying that electric component is parallel to optic axis. So always remember, whenever incident electric component is parallel to optic axis, it will propagate as E ray, and on the emergent side we will have same plane polarized light. So in case 5, if theta is 90 degree or 270 degree, then what will happen? Then we have this type of case. This is optic axis, this is optic axis, and electric component is in perpendicular direction. This is 90 degree, this is 90 degree here. So we have an electric vector which is perpendicular to the optic axis, so there will be no component of this electric vector parallel to optic axis. So we will have only one component that is in perpendicular direction to the optic axis. So this will act as O ray. And because there is no component parallel to the optic axis, we will not have any E ray. So in this case, we don't have E wave. There is no E wave in this case. We have only O wave, ordinary wave. This will propagate through the crystal as O wave, and there will be no double refraction, no phase difference, no part difference, because other wave is not there present. So there is no question of part difference or phase difference. It will propagate as O wave, it will pass through the crystal, and on the emergent side we will again have plane polarized light. So what do you understand? What do you understand from these two cases? The meaning of this is, if electric component of incident plane polarized light is parallel to the optic axis, then it will propagate as E ray. Or if electric component of incident light is perpendicular to the optic axis, then it will propagate as O ray. In both cases there will be no double refraction, because that electric component cannot be resolved into two parts. Only either E wave is present or O ray is present. So there will be no double refraction, there will be only a single wave, either E wave or O wave. There is no part difference between them, there is no phase difference between them, no double refraction, so they will propagate as O ray or E ray, and on the emergent side we will have same plane polarized light. Now come to seventh case, case number 7. Now come to case number 7. If we have delta, if our delta is not equal to the multiple of 0 degree, pi by 2 degree, pi by 2, pi, 3 pi by 2, and 2 pi. If our delta is not like this, then what will be the shape? In that case, suppose delta is equal to 67 degree, then we will have this type of equation, and on the emergent side we will have elliptical polarized light, elliptically polarized light, elliptically polarized light. So if delta is not equal to these, then delta can have any value there, like 67 degree, 37 degree, 33 degree, 167 degree, whatever is its value, but this delta is not equal to these, then on the emergent side we will have elliptically polarized light. But remember, this is not rectangular ellipse. This will not form rectangular ellipse, but this will be elliptically polarized light, and this elliptically polarized light will have this type of electric configuration. We will have this type of elliptically polarized light. So this type of elliptical polarized light will be there. Only this will not be, certainly this will not be rectangular ellipse, but other type of ellipse will be there. So these are all 7 cases. These are the 7 cases, and I have discussed one by one with you all these cases. So you should remember these cases one by one in sequence. You should remember all these cases. You should remember what is case number 1, 2, 3, 4, 5, 6, 7. If you remember all these cases, then you can solve most of the questions related to double refraction. Now, next topic is quarter wave plate or retarding plate. Next topic is quarter wave plate. Quarter wave plate. What is the meaning of quarter wave plate, or what is the meaning of retarding plate? Basically, what is happening in double refraction, when a light is incident, on a doubly refracting crystal, and this double refracting crystal is cut in such a way that optic axis is parallel to its face. We have optic axis parallel to its face. This is the face of the doubly refracting crystal, and cutting is such that the optic axis is parallel to this face. If we have this type of doubly refracting crystal and a plane polarized light is incident on this, making some angle, then it will be resolved into this electric vector can be resolved into 2 parts, one parallel to the optic axis, another perpendicular to the optic axis. One will act as E ray, another will act as a O ray. Now both O ray and E ray, they will travel inside the board, and one after the another, and a part difference and phase difference will be present in between them when they are emerging out of this crystal. Suppose thickness of the crystal is T. So there is a part difference or phase difference between them. So this part difference and phase difference that is introduced by this plate, that will be responsible for the development of quarter wave plate and half wave plate. Now, what is the meaning of quarter wave plate? Quarter wave plate, in quarter wave plate, thickness of this doubly refracting crystal is such that the part difference introduced in between O ray and E ray, that is exactly equal to lambda by 4. So what is the meaning of quarter wave plate? In quarter wave plate, we have a doubly refracting plate in whose thickness is such that the part difference introduced between E ray and O ray, this is the part difference introduced between O ray and E ray, this is the optical part difference, this will be equal to lambda by 4. Then if O ray and E ray, the part difference introduced between O ray and E ray is lambda by 4, then this plate is known as quarter wave plate. So basically the role of quarter wave plate is it introduces a part difference of lambda by 4 in between O ray and E ray. But here one important thing is both O ray and E ray, they are moving one after the another, and this is possible when we have a crystal whose face is this. Optic axis will be parallel to this face, and thickness is inside this board, and light is incident on this in this way, and is normally incident on this. So in between O ray and E ray, if this thickness is such that this optical part difference is λ/4, then that type of retarding plate is known as quarter wave plate. Retarding plate means it is introducing some part difference or phase difference between O ray and E ray. Any plate which is introducing between some part difference or phase difference between O ray and E ray, and have optic axis parallel to this face, which have this type of structure, that is known as retarding plate. Quarter wave plate and half wave plates are its example, are two of its examples. So in quarter wave plate, mu E minus mu O into T equal to λ/4. This is the most used expression, but journal expression in journal, it can be written as mu E minus or difference mu O into T equal to 2n plus 1 λ/4. This is the journal expression. And what is the role of this quarter wave plate? The role of this quarter wave plate is it is introducing a phase difference, or it is introducing a part difference of λ/4, which is equivalent to the phase difference of pi/2. So what this quarter wave plate is doing? This quarter wave plate is introducing a phase of pi/2, a phase of pi/2 between O ray and E ray. Now this quarter wave plates has many applications due to the introduction of this phase delta equal to pi/2. First, I will discuss one by one. So here this λ/4 is equivalent to pi/2. So if we have a plane polarized light, suppose for this delta is 0, is incident on quarter wave plate, which is introducing a phase of pi/2, then on the emergent side, what we will have? We will have a phase delta. 0 was here, pi/2 is introduced, so here this will be 0 plus minus pi/2, so phase will be here pi/2. And if in this case, if theta is not equal to 45 degree, then on this side we will have elliptically polarized light. This is the case 1. I have discussed 7 cases with you. Here this PPL is suppose belonging to case 1, then here this will belong to case 3 when theta is not equal to 45. What is this theta? Theta is the angle between optic axis and electric vibrations. If suppose this is the electric vibration, then the angle between the optic axis and this electric vibration is theta. If theta is not 45 degree, then on the emergent side we will have elliptically polarized light. This is the first application. So with the help of this quarter wave plate, we can produce elliptically polarized light. Now if this theta becomes 45 degree, then phase will still remain. This delta is different. Delta was 0 initially, quarter wave plate introduced an extra phase of pi/2. So here total phase delta will be pi/2. So either it will be circularly polarized light or it will be elliptically polarized light. But here this theta is 45 degree. When theta is 45 degree, then its component parallel to the optic axis and perpendicular to the optic axis, they will be equal, and we will have circularly polarized light here. So in this case, when theta becomes 45, we will have circularly polarized light. So this is the second application. Now come to the third application. of this quarter wave plate. If we have this quarter wave plate and a circularly polarized light is incident on this, for circularly polarized light, delta will be equal to pi by 2. And pi by, this is quarter wave plate, and pi by 2 phase is introduced by this quarter wave plate. So now on this side, what we have, we will have delta, either this will be pi by 2 plus pi by 2, or this will be pi by 2 minus pi by 2. So pi by 2 minus pi by 2 0, or pi by 2 plus pi by 2, this will be pi. So on the emergent side, we will have phase that will be equal to 0 and pi, and 0 and pi phase is corresponding to case number 1 and 2. So on this side, we will have PPL, plane polarized light. If a circularly polarized light is passed through the quarter wave plate, then on the emergent side, we will have plane polarized light. In a similar fashion, if elliptically polarized light, rather than I will say rectangular elliptical, this is rectangular, more specifically rectangular elliptical polarized light, when this is incident on the quarter wave plate, then this delta will be pi by 2, and this will introduce a phase of pi by 2. So this will be pi by 2 plus pi by 2, pi by 2 minus pi by 2. So delta will be 0 and pi, and again we will have PPL on the emergent side. So these are the 4 applications of quarter wave plate. So a retarding plate which is introducing a phase of pi by 2 or a part difference of lambda by 4 in between E wave and O wave, that plate is known as quarter wave plate. This quarter wave plate is very useful. It can convert PPL light into plane polarized light into circularly or elliptically polarized light, and it can also convert circular and rectangular elliptically polarized light into plane polarized light. So these are the 4 applications of quarter wave plate. Now come to half wave plate. Next is half wave plate. Half wave plate is that retarding plate which introduces a part difference of lambda by 2 in between E ray and O ray. So for half wave plate, this is mu E difference mu O into T is equal to lambda by 2. And lambda by 2 part difference is corresponding to phase difference of pi. So half wave plate is that retarding plate which introduces a phase of pi between O ray and E ray. Now this is the formula, most general formula will be mu E difference mu O into T equal to 2n plus 1 lambda by 2. This is the most general formula, 2n plus 1 lambda by 2. This is the general formula, and this is the formula many times we will use, mu E minus mu O into T equal to lambda by 2, but the main purpose is to introduce a phase of pi. This plate introduces a phase of pi in between O ray and E ray. Now what is the application of this? Application of this is very important, of half wave plate is very important. Suppose a PPL, plane polarized light, is incident on this, this is half wave plate. This half wave plate is introducing a phase of pi. Suppose for this PPL is of case 1. So delta I am assuming 0. So I am assuming that we have a simple PPL like this. This is we have simple plane polarized light for which delta is 0. Now what will happen? Suppose the electric vector of this is making angle theta degree. So this plane polarized light is like this, as I have drawn in the, so here I have this type of plane polarized light which is making angle theta. So this component is E naught x, this component is E naught y. Now this is plane polarized light, so Ey upon Ex will be equal to the slope of this. This is tan theta. Tan theta is equal to E naught y by E naught x. So I can write this equation as Ey equal to Ex. So this is a linearly polarized light or plane polarized light. When this plane polarized light is incident on this half wave plate, then this half wave plate introduces a phase of pi. So this will be 0 plus minus pi. So here at this place delta will be equal to pi. So here we have plane polarized light of case 1. And here again we will have PPL, but here delta is pi. So this belongs to case 2. This is case 2. What type of so this is the incident light, and what will be the emergent light? Emergent light, this will be the emergent light. Here this will be the emergent light. This will be the emergent light. This is incident light. So on the emergent side we will have plane polarized light, but its electric vibration will be rotated by an angle theta, by 2 theta angle. So here this was making an angle theta, but here its equation will be Ey equal to minus, this will be minus tan theta, so it will be E naught y upon E naught x into Ex. Again this is linearly polarized light, but its electric vector is making an angle minus theta with respect to optic axis. So what is the role of half wave plate? Half wave plate rotates the electric vibration by an angle 2 theta around the optic axis. This will not rotate like this. This will rotate like this. This angle by which it is rotated, that is equal to 2 theta. So this is the role of half wave plate. So when plane polarized light passes through the half wave plate, it will remain plane polarized light, but its electric vibration or its electric vector will be rotated by an angle 2 theta. Around which axis? Around optic axis. Most important point is that this electric vector will rotate around the optic axis. You should remember this point. So this is the main role of half wave plate. Apart from this, it can be used for converting right elliptically if suppose this is for 2 other purposes also. Suppose this is half wave plate, and on this half wave plate suppose left elliptically polarized light is incident, then on this side we will have right elliptically polarized light. What is the meaning of right and left elliptically polarized? I will discuss in the next lecture, but still you can remember that when left elliptically polarized light is incident on half wave plate, it will convert into right elliptical polarized light. And if right elliptically polarized light is incident on this, it will convert into left elliptically polarized light. In a similar fashion, if left elliptical or left and right circularly polarized light, left circularly polarized light is incident on this, it will convert into right circularly polarized light. And if right circularly polarized light is incident on this, this will convert into left circularly polarized light. So this will change the polarization from left to right and right to left for elliptical as well as for circularly polarized light. So these are the 3 important applications of half wave plate. So up to this point I have discussed 7 cases one by one. First case when delta was 0, 2 pi, 4 pi. Second case when delta was equal to pi, 3 pi, 5 pi. After that I have discussed the case when delta is pi by 2, 3 pi by 2, then we are getting rectangular elliptically polarized light. In fourth case, when delta was equal to pi by 2, 3 pi by 2, 5 pi by 2, but theta was equal to 45 degree, we were getting circularly polarized light. After this, today I discussed 3 more cases when theta is 0 or theta is 45 degree, and in last when delta is not equal to 0, pi, pi by 2, 3 pi by 2, like this. You should remember all these cases. Apart from this, I have discussed quarter wave plate, what is the meaning of quarter wave plate, what is the meaning of half wave plate, what is the formula used here for part difference. And after this, I have discussed their application. So you should remember everything very clear in your mind. If you have any difficulty or any doubt, you can write in comment option, or you can write on my WhatsApp. Thank you.